In the cold, lifeless silence of space, there's a secret no one expected. A world long believed to be bone dry, holding a shimmering promise beneath its dusty skin. A place where water shouldn't exist, yet it does. But here's the twist, it wasn't brought by comets. It didn't come from ancient ice. No, it might be born from the sun itself. What if I told you the blazing solar wind, those streams of deadly particles hurled across space, might be creating water on the moon? Buckle up, space explorers, because what you're about to hear will shatter everything you thought you knew about how water exists in the universe. The moon, a silent, ancient world, orbiting our Earth for over 4.5 billion years. For most of human history, it was thought to be a barren desert, no air, no life, no water. Apollo astronauts kicked up fine, gray dust, not a drop of moisture in sight. But in recent decades, spacecraft peering into lunar craters and sunlit plains started detecting something bizarre. Signatures of hydrogen, hints of hydroxyl and even water molecules, right there, where it was never supposed to exist. How could this be? Where was this mysterious water coming from? Could it be buried ancient ice? Maybe delivered by crashing comets? Or, was there something even stranger happening? Now, to understand this mystery, we have to look 150 million kilometers away, to the heart of our solar system. The Sun, a giant ball of nuclear fire, constantly throwing off streams of charged particles, called the solar wind. These invisible streams race across space at blistering speeds, carrying with them high-energy protons, essentially hydrogen atoms stripped of their electrons. When they strike a planet with an atmosphere like Earth, we get auroras. But on the airless moon, it's a different story. The moon's surface is covered in regolith, a fine, jagged dust made of oxygen-rich minerals. And when those protons hit, they crash into oxygen atoms in the dust, bonding together to form something new, hydroxyl, OH, and sometimes, full water molecules, H2O. To test this mind-blowing theory, NASA recreated lunar conditions in a lab. They blasted simulated moon dust with high-energy protons, mimicking the relentless attack of the solar wind. The result? Water molecules formed, right there, on grains of lunar regolith. This experiment confirmed what satellites like Chandrayaan-1, SOFIA, and the Lunar Reconnaissance Orbiter had been hinting at. Not only could water form on the moon's sunlit surface, it was happening all the time. And here's where it gets wild, those newly formed molecules could hop around the moon's surface, migrating toward colder, shadowed regions near the poles, where temperatures plunged to minus 240 degrees Celsius. There, water could accumulate, trapped in craters that never see sunlight, essentially creating cosmic water vaults. Why does this matter? Well, for one, water is life. But beyond drinking and growing plants, water can be split into hydrogen and oxygen, essential ingredients for rocket fuel. If astronauts can harvest water directly from the moon, not just from ancient ice, but from this ongoing process driven by solar wind, it could power future lunar bases, enable deep space missions, and even support colonies on other worlds. Imagine future lunar missions carrying simple equipment to process regolith, extract hydrogen and oxygen, and produce water and breathable air, without the need to haul it all from Earth. And here's the next mystery. If this process is happening on the moon, could it be happening elsewhere? If solar wind-driven chemistry is this effective, it changes our understanding of how water could be distributed throughout the solar system, and maybe even beyond. Planets and moons long thought to be dry might hold hidden caches of water formed by the sun itself. What we're starting to see is a kind of cosmic water cycle. Solar wind delivers protons. Lunar regolith supplies oxygen. Together, they create water molecules, which can migrate, accumulate, or be broken apart again by radiation. This ongoing process blurs the lines between dry and wet worlds. It suggests that water, one of the most precious resources for life, might be more common than we dared imagine, quietly being made by the stars themselves. The idea that the sun, a fiery sphere of plasma, might be creating water in the cold, dead dust of the moon is one of the great surprises of modern space science. It shows us that the universe is endlessly inventive, that even the harshest, most unlikely environments might hold the ingredients for life, survival, and exploration. And who knows, as we step onto new worlds, we might find that the sun has left us more gifts than we ever imagined, hidden in the dust, waiting to be claimed by the explorers of tomorrow. This is the beginning of a new age of discovery, where sunlight creates water, deserts hold life, and the impossible becomes reality. Stay curious, space travelers, because the universe is only just getting started.